Good morning, everyone. Today we will discuss, we will learn something new in the area of physics that comes under the modern physics, developed from the 1900, comes under the modern physics. Now, whatever the concepts or applications we are enjoying, and whatever the research is going on in all over the world after the 1900, it comes under the modern physics. Before that, it comes under the classical physics. So in this modern physics, we have three areas, three concepts: photoelectric effect and optical fiber and lasers. uh, Today in this session we will discuss about optical fiber area. In next sessions we will discuss about photoelectric effect and another one is a laser. So today we are going to discuss about the light properties, that is reflection of light and refraction of light, and special cases of refraction, that is total internal reflection and optical fiber. What is optical fiber? Construction of optical fiber, working principle of optical fiber, types of the optical fiber, and applications of the optical fiber in various fields. These topics will cover in this session, in this lesson. So first, reflection. So everyone is aware about reflection. We are studying this reflection concept from standard 7th and standard 8th. The phenomenon of bouncing back of light when it incident on any surface is called as a reflection. The example, if you throw a ball to a wall, the ball incidents on a wall and then it comes back to you. The same case takes place in the light also. So when light incidents on any surface, some of the surfaces are transparent, some of the surfaces are opaque, and from any surface the light ray bounces back into the same medium is called as a reflection. Here see, the light ray is coming from the torchlight and it falls on this surface. This is the incident radiation, then it comes back, right? The ray which is coming is called as an incident, and which is reflected is called as a reflected ray. Incident ray which is coming from the source, and a ray which bounces back into the same medium is called as a reflected ray. Draw a normal to the surface. Draw a normal to the surface. This is the normal drawn to the surface, right? Draw a perpendicular, draw a normal to the surface. Then these incident ray and reflected ray are lies either side of a normal. It lies either side of a normal. The angle between the incident ray, angle between this incident ray, this is the surface, this is the normal, and this is the reflected. So angle between this This is taken as I, this is taken as R, incident ray, and this one is a normal to the surface. The angle between the incident ray and normal is called as incident angle. Consider it as theta 1. And angle between reflected ray and normal is called as a reflected angle, that is taken as theta 2. So these are this theta 1, this theta 1 always equals to theta 2. So incident angle is equals to reflected angle. Sometimes this theta 1 is taken as theta I, incident angle, and reflected angle theta r, both are equal. Theta I, theta r are equal, and incident ray and reflected ray lies either side of a normal. Incident ray normal drawn to the surface, and refracted ray are in a same medium. These are the laws of a reflection. Next point, when the ray is passing from incidents on any surface, some of the ray bounces back and some of the ray enters into the other medium. When it enters into the other medium, then it bends and it moves in the other medium. The phenomenon of bending of light when it passes from one medium to another medium is called as a refraction. The bending of a light when it passes or when it travels from one medium to another medium is called as a refraction. Here observe that for example, this is a surface and this is the normal drawn to the surface. Here air, this one is a glass. Comparatively, glass is a denser medium, air is a rarer medium. So refractive index of air is taken as 1 and another one is taken as 2. Now the ray is coming from the source in air and it is incidents on the surface which separates the two mediums, air and glass. Some of the ray bounces back and some of the ray enters into the second medium. This incident one is taken as incident ray. This is this ray bends at the end, bends at a surface. This bending property is called as a refraction. The ray which is coming from a source is called as an incident ray, and which bends see this figure, which bends and enters into the another medium, that is called as a refracted ray. So the angle of incident is taken as the angle between the incident ray and normal reaction, and angle between normal and refracted ray is taken as a angle of refraction. So this reflection and refraction are two different phenomena. In reflection, the ray comes in the same medium, bounces back into the same medium. In refraction, the ray enters into the other medium. Ray enters into the other medium. Here you observe, you put a stick in a bucket of water, then the stick appears to be bent at the surface of water and air. Such same you drop a 2 rupee coin or 5 rupee coin, any coin in a bucket of water. When the coin reaches to the bottom of the bucket, then you can see the coin placed at the bottom appears to be raised. These are the examples for the refraction process. Refraction, the incident radiation enters into the second medium and it bends and enters into the second medium. In lower classes, high school, you studied that light is bending towards this normal. Is the light bends away from the normal also? Yes, it bends away from the normal also. But depends on from the light traveling from where to where. In general, till today or before classes, we studied the light ray is bending towards the normal. In all the pictures in high school, you saw that the light is bending towards the normal. But in that case, the light is moving from the rarer medium to denser medium. If in reverse process, see the light is passing from the denser medium to rarer medium, then the refracted ray bends away from the normal. The incident ray and refracted ray and normal lies in the same plane in this refraction. In the reflection, the incident ray, reflected ray, normal lies in the same medium. But in refraction, the incident ray, refracted ray and normal lies in the same plane. The incident ray and refracted ray are on opposite sides of the normal at the point of incident. At the point of incident ray and the refracted ray are on opposite sides of a normal. And the laws of refraction obeyed by the Snell's law. Snell's law gives the ratio of sine angle to the ratio of the sine angles of incident to the sine angle of refraction is constant. This ratio is called as a refractive index. So here ratio between the incident sine value of incident angle and sine value of refracted angle gives some constant. That constant is known as a refractive index. It is represented by mu. If mu is greater, the refractive index is greater, the bending of light is also greater. Right? Means the refractive index is more for the denser mediums. So if the density of the medium is more, it bends towards the normal because the velocity of light decreased by the density of the material. For example, you are moving on a highway, or you are going from here to your homes. If traffic is less, you will move fast. In market areas or bazaar areas, the more traffic at the place, more traffic or the more people are there on the road, then automatically you slow down, your vehicle speed goes down, you have to slow your vehicles because the density of the public. In the same manner, the medium density is more, so velocity also decreases. Velocity decreases, so the light ray bends towards the normal. If you are passing the traffic area, you are passing the public area, there is no public on the road, no traffic on the road, then automatically you goes fast, right? In the same manner, when the light is coming from the denser medium to rarer medium, automatically the light velocity increases. Light velocity increases, that's why it bends away from the normal, and this gives the Snell's law. Snell's law is a, you can say that sine I equals is directly proportional to sine r. If sine value of incident angle increases, sine value of refracted also increases. The ratio between sine I and sine r gives the constant. That constant is refractive index of the medium. You now you for example, the light ray is coming from the denser medium and going to the entering into the rarer medium, then it bends away from the normal. Still you are increasing the incident angle, automatically refracted angle also increases. Refracted also increases. Still you are increasing at certain incident angle, the refracted ray passes through the surface which divides the two mediums. Means the refracted ray angle becomes 90. The angle between the normal drawn to the surface and the refracted ray becomes 90. That incident angle, at which incident angle the refracted angle becomes 90, that incident angle in the denser medium is called as a critical angle. That is called as a critical angle. If still you are increasing the incident angle, automatically the refracted angle also increases. So the light is passing from the water and refracted into the air. You are increasing the incident angle. At certain angle, the value becomes, refracted value becomes 90. At this angle the value becomes 90. Here 90. This is the theta. This is called as a critical angle. At which angle the refracted angle becomes 90, then this angle is called as a critical angle. Now you increase the incident angle, refracted angle also increases, the more than 90 degrees. Now this, observe this, the total energy coming from the denser medium totally bounces back into the same medium when the angle of incident is greater than the critical angle, right? Actually, when the light is passing from the denser to rarer medium, incident angle is greater than that of critical angle, then ray, instead of bending, it reflects back in totally into the same denser medium. This phenomenon is called as a total internal reflection. The phenomenon when a light ray passes from a denser medium to rarer medium with an incident angle is greater than the critical angle. The ray is not refracted into rarer medium, but it is totally reflected into denser medium. This phenomena is called as a total internal reflection. You can see here the red laser beam light passing through a crystal. It is totally in water, entered into water and totally reflected back into the same medium. In the first picture also you can see the light, some of the light is reflected and some of the light is reflected and some of the light is refracted. When the incident radiation is incident angle is greater than the critical angle, then the total energy. See here, third case, some of the energy is going back and some of the energy refracted. At this condition, total energy is reflected back. So total internal reflection takes place there. So here for total internal reflection, the light should travel from a optically denser medium to optically rarer medium, and the angle of incident should be greater than the critical angle. The light should pass or travel from the optically denser to optically rarer medium, and the angle of incident of light should be greater than the critical angle, and the light should travel from a medium of higher refractive index to lower refractive index. These are the conditions for the simple harmonic motion. Sorry, these are the conditions for the total internal reflection. So, if the light is passing from the rarer to denser, no total internal reflection takes place. And if it is traveling from the lower refractive index to higher refractive index, it is not takes place. And if the angle of incident is not greater than the critical angle, then also total internal reflection does not takes place. These are the conditions for the total internal reflection. So applications of this total internal reflection is a optical fiber. The optical fiber is a cylindrical or rectangular dielectric waveguide which transmits the light along its axis by without any loss by the process of total internal reflection is called as a optical fiber. The optical fiber is a thin wire made up of plastic or glass that transports the light energy from one place to another place without much loss by the principle of total internal reflection. In another way, you can say that it's a cylindrical or rectangular dielectric waveguide which guides the wave to transmit the light through its axis is called as a optical fiber. Optical fiber brings the lot of change in the communication internet area. The electronics and communication area drastically changes by the introduction of the optical fibers into the field, and also medical field and communication, telecommunication, internet communications. The total area is drastically switched to new generation with the help of optical fiber. Optical fiber basically contains three areas, which is first one, inner area is a core, then second one is a cladding, and outer area is a coating, which also called as a sheath. This core area is a waveguide area. That area has a more refractive index compared to the cladding. This core and cladding are the main parts of the optical fiber. The cover or coating or sheath is known as a safety purpose. The optical fiber is a long cylindrical or rectangular structure, generally with circular cross sections, a small diameter, order of few microns. It has two coaxial regions. The inner solid region is having a higher refractive index. It guides the co it guides the light to pass through the optical fiber, and that is called as a core. So core area has a higher refractive index and which guides the light, and it is coated with a thin layer of material of lower refractive index, comparatively lower, that is called as a cladding. The inner solid core acts as a denser medium, and outer core coating area, that is cladding, act as a rarer medium. Due to this change in the refractive index, total internal reflection takes place. Due to this total internal reflection process, light travels without leakage through the side walls. Right? To confirm the optical signal into the core, the refractive index of the cladding must be small comparatively that. The boundary between the core and cladding may either be abrupt or in step index fiber or gradual in graded index. We will discuss about the different types of optical fibers in a few minutes. So here how this optical fiber works. Optical fiber has basically two major main area parts, that is a core and cladding. Optical fiber, you see here the this yellow spot, yellow region is a core area, and outer coated one cladding, and next one is the buffer, or it is called a sheath, or it is called cover. So light ray enters into the core only, and total internal reflection takes place in the core area only. So core, cladding and buffer are coating area. Here the light passes in the core area only. This is the structure of the optical fiber. Next, how this optical fiber works. How this optical fiber works. This optical fiber works on the principle of total internal reflection. Total internal reflection takes place when the light is traveling from the denser medium to rarer medium, and the incident angle must be greater than the critical angle. See here, optical fiber consists of three layers. They are the core, cladding and sheath. The refractive index of a core is taken as N1, and refractive index of cladding is taken as N2, which act as a rarer, core act as a denser medium. The sheath is a coaxial layer which protects the optical fiber. When light is incidenting on the optical fiber with an angle, incident angle, uh, which is greater than the critical angle. Here this is the incident angle, the angle, this is the, sorry, this is the incident angle, normal and incident ray. This angle is greater than the critical angle. The light enters and propagate through a curved optical fiber. The light travels through the fiber by means of total internal reflection because light ray is completely confined into the inside the fiber. When light rays enter the optical fiber, it travels through the core and cladding. At their boundary, core and cladding boundary, core and cladding boundary, the light ray undergoes total internal reflection and reflects back, and again the total internal reflection takes place at the boundary. So observe, see here, at this total internal reflection takes place, and this comes, travels, and at this boundary total internal, and at this boundary, at every boundary of core and cladding total internal reflection takes place. This process is repeated until the light ray is emerged at the other end of the fiber. So here the light ray is transported from one place to another place through the optical fiber. The light ray is confined to the core area in the optical fiber. So at the surfaces, boundaries of the core and cladding, the light ray reflected, total internally reflected in the core area only. So core area act as a denser medium. So the principle of total internal reflection applied to all the optical fibers irrespective of their dimensions or shape. In case of infrared light, the loss of energy is less that of to the visible or ultraviolet radiation. The light ray passes from a denser medium to rarer medium, means from core to cladding, with the acceptance angle of 90 minus alpha. Here alpha is the incident angle. The light ray undergoes total internal reflection. Alpha is a incident angle. This angle is called as the acceptance angle. The angle at which the light enters the optical fiber. At which angle the light enters into the optical fiber, this angle is called as a acceptance angle. Here the optical fiber is accepting this angle, accepting the light into the core area, and at the end of the optical fiber, other side of the optical fiber, light energy emits out from the optical fiber. At which angle the light emits from out other end of the optical fiber is called as a emission of the optical fiber. So the angle at which the light enters into the medium or enters into the optical fiber is called as acceptance angle, and the light leaves the optical fiber, at which angle that angle is called as emission angle. Here, how much light can be collected in an optical fiber? So the gathering capacity of an optical fiber, or the quality of optical fiber, can be given by the or ability of an optical fiber to allow the light. How much light can be collected in optical fiber? There is a numerical aperture. The numerical aperture considered as a light gathering capacity of an optical fiber. The ability of optical fiber can be given by the numerical aperture of an optical fiber. This numerical aperture is essential for the selection of optical fiber for different applications. The selection of optical fiber for different operations or applications are based on the numerical aperture of that particular optical fiber. Numerical aperture is the ability of gives the ability of optical fiber how much light can be collected by an optical fiber. This numerical aperture can be given by Na equals to root of mu 1 square minus mu 2 square, where the n is a numerical aperture, mu 1 is a refractive index of core material, mu 2 is a refractive index of a cladding material. Mu 1 is a refractive index of core, mu 2 is the refractive index of a cladding. This gives the ability of optical fibers. So based on the structure and their refractive indexes, the optical fibers are divided into two types. One is step index optical fiber and another one is a graded index optical fiber. So step index optical fiber has different refractive indexes of core and cladding. The refractive index of core will be high and refractive index of cladding will be low. This type of step index optical fibers are used for the illumination purpose. So in the step index optical fiber, the refractive index changes drastically like steps. So the cladding and core, for example, the core at the boundary of core and cladding, the refractive index changes drastically. For example, 1.5, 1.7 is the refractive index of the core. Then you enter into the other plane or other side of a boundary, then the refractive index changes to 1.3 or 1.4. Drastically changes like step. So these type of optical fibers are named as a step index optical fiber. These type of optical fibers used for the illumination purpose. And second one is a graded index optical fiber. So it contains a core with the refractive index decreases gradually. The refractive index of core decreases gradually from its axis. From its axis towards the cladding area, the gradually decreases refractive index it has. The higher refractive index at the center makes the light ray moving down the axial line axis advance more slowly than those near to the cladding. So this is a type of graded index optical fibers used for the telecommunication and other uses with the source of laser lights. Here in graded index, we use the source as a lasers, and these graded index optical fibers are used for the telecommunication purpose. The refractive index of the core gradually decreases when you move from axis of the core to the cladding. These are the two types we have in our syllabus. Based on different criteria, we have different types of optical fibers. Next topic is the applications of the optical fibers. These optical fibers are used in various fields of science and technology and various applications we have throughout the world. The optical fibers are used for the communication in between the military persons. In military communication, we are using optical fibers because of the high security and low leakage and less maintenance, and these optical fibers can work at very drastic change environments like very hot areas and very cool areas also, they work without any interruption. That's why military communication, we are using the optical fibers in the military communication. And using these optical fibers in telecommunication, the information carried by the optical fiber is several times greater than the electricity or radio waves. You can send a high data, very huge information through a single optical fiber. If you use cable wires, so 1500 cable wires, you can send the data which is sent by the 1500 cable wires. That huge amount of information data can be transmitted through a single optical fiber. So we are using these optical fibers in the areas of telecommunication and in the area of net connections, internet cables, telecommunication cables, and TV connection cables. We are using these optical fibers to connect computers from one computer to another computer, from database to computer. We are using cables, optical fiber cables, to connect the computers and internet cables. And you are using cables, TV connection. And we are using these optical fibers as decorative flower vases. You can, everyone has seen some white threads fixed in a small pot, gives the lights, and the end of the fiber, they are placed in counters and so many shops and so many shopping malls. Everyone has seen this. These are the optical fibers, and these optical fibers are used as a scientific instruments to illuminate the objects in the scientific society and research areas, and in the scientific research centers where using these optical fibers are scientific instruments. And we are using these optical fibers as a sensors in industries and different areas like civil engineering, medical, other mechanical engineering, strain gauges. We are using these optical fiber sensors in the various fields to identify the different problems. They are using as a sensors in the industry and in the fields of construction, in the fields of manufacturing, in the field of medical. We are using these optical fibers. In medicine, we are using these optical fiber as a diagnostic equipments, uh, like laparoscopy and endoscopy, to illuminate the inner part of the body, to see the inner part of the body, to find out the various obstacles in the uh, flow of blood vessels into the heart, and the tumors developed in inside the intestines in any part of the body. We are using the sensors, we are using the optical fiber technology and optical fibers in the field of medical. In this endoscopy and laparoscopy, we can illuminate and we can observe the internal parts of human body. These are the advantages, and these are the mostly widely used areas of optical fiber. We are using a lot of if you go entered into the individual fields for like medical, like civil engineering, like in civil engineering you can use as a sensors to find the damages of the buildings, find the damages or workload gauges of the old bridges, right? You can find out the strength of the building bridges, strength of the pillars by using sensors of optical fibers. And we are using this in the decorations. So we have a wide range of applications of optical fibers. In this session, we discussed the basic concepts of principle of optical fiber, that is total internal reflection, and optical fiber. What is optical fiber? Construction of optical fiber and how it works. The optical fiber works on the principle of total internal reflection, and the types of reflection and the applications of reflection. So hope you got the concept uh, about the optical fiber. This is a most advanced and you can learn and you can work on this area. Wide range of application, wide, it has a wide scope for doing research and any other projects under your diploma or any branch, irrespective of branch. The most of the people feel that the optical fiber related to the communication or EC or E, not like that. It is not as computer science. It has a wide scope. You can use these optical fibers in any field of mechanical, civil, mining. You can use those optical fiber sensors to find out the gases, dangerous gases which are produced by the produced in the mines, right? So in civil, you can find out the damages and the strength of the old bridges, like that. You can use in any field. You can use biomedical engineering. Everywhere we are using these optical fibers. We had a great scope of optical fibers. Hope you got the concept and understand the optical fibers. Thank you everyone. Thank you.